So let's talk about the Forest Maker. Let me take you up to the forest again and show you how it looks. Let's get up here, right up in the corner. So the premise of this Forest Maker is that we want to render the forest everywhere except for within the play area. And what we want to do additionally is we want to give it sort of an organic feeling. And when I say organic, what I mean is these trees are actually all aligned on a grid system. For every block, there's one tree or one bush. And when you do that, in fact, I will turn off the randomization portion that makes it feel more organic. And you'll see what I mean about a grid system. Let's go ahead back up here. And let's do this.
So the forest is randomly placed or generated?
It is not randomly generated.
Oh.
That's what I'm trying to demonstrate here.
Oh, okay.
So it's laid out on a grid. This is how it's initially laid out. Very grid-like. This is where it started. So let's back up. First of all, Forest Maker is exactly the same code as, where is it? Ground Maker? Yeah, Ground Maker. I derived it from Ground Maker. And what I did was I said, lay out a grid, but if that grid hits one of these places, basically it's within the limits, which is the limit, the bounding limit for this area. If it's within there, don't render anything. So create something if it's outside the limit. If it's inside the limit, create a tree. And that's what this little piece of code here does. So this is slightly different from the Ground Maker code, so you can compare the two side by side. But assuming that you get into this code and it's okay to create a tree, you randomly select one of 32 trees, and there is a sprite sheet that has 32 trees. You choose one of those, and then you place it at the current XY grid that you were normally going to place a ground tile at, because it's the same code, similar code. So we'll place a tree, and as you can see, it looks terrible. I mean, it's clearly artificial. So the first step to making this less artificial is to keep our current XY position, but add a little bit of randomness to it. So what we're doing here is we're saying the X position is going to be our current X plus a random value between -10 and 10. Similarly, we're going to do the current Y, -10 and 10. And then when we run that, now it's going to look a little bit better. So now it looks, you can see that it's no longer grid-ish. I mean, it's still a grid, but it's no longer perfectly aligned. There's slight deviation. But that's still not good enough. The other problem here is the trees are significantly smaller than what we need. And so experimentally, what I did was I said, okay, instead of making the tree size the same as the grid, choose a random number. And if you're not familiar with mrand, mrand is my localization of math random. So it's just a shortcut for keeping me from having to type that every time, and it gives me a slight speed up because I've localized the function. So mrand 2 to 2.5 multiplied by the grid size. In other words, the trees, every time I place one, it's going to be within 2 to 2.5 times the grid size. And as soon as I do that, I get, did I save it? No. I save it and do that, we get this. Now, it feels much better. It's a bit crowded, honestly, but as a first pass for a very simple algorithm for placing a bunch of trees which bound our area, which is all I wanted to do, and I also wanted to give you just a few gaps so you can kind of see that the zombies are coming sometimes, but not always. This works just fine.
Yeah, it has an organic feel to it.
And it has this organic feel because the sizes all vary slightly, the placements all vary slightly, and we randomly choose our trees. So clearly I could have, some of these trees don't go with some of the other trees, like this tree here doesn't really go with the deciduous and whatever. But the point was to get something in there fast and furious for the demo today. People can refine this to their heart's content.
The reason I was asking about the random part was that Stephen had said in the comments he was thinking about how to make the trees look like they're rustling using some kind of shader or color alpha.
Oh, sure. Give me more work to do.
Yeah.
You could do
Yeah.
that. You could do that. Or you could here, we could take that one level up. You could have the trees that are near the zombies rustle.
Oh, that would be cool.
See? Because then you'd get this clue. You'd see a rustling, little rustling on the edge of the tree, the boundary. You'd be like, oh, got to get myself away from there.
That's where the velociraptors are.
Yeah, I'm thinking there's a lot of structure. There's the shadow at the bottom. There's a trunk is about half of it, and then there's foliage on top. You could exploit those ratios a lot.
I'm glad you mentioned that because actually I didn't show this in the code just now when we were talking about it. But when I render these trees, I render the tree with no shadow. So I've taken the image that was originally in the Reiner set and I cut out the trees and took the shadows out. So I render those in one layer. I render those in the overlay layer. And then in the underlay layer, where the ground goes, is where I put the shadow. So if we're looking at the Forest Maker, you'll see me do that. I create the tree image, which is like the green and brown and all that, and I put it in, I'm sorry, tree sheet. No, I create the shadow, and I put that in the underlayer, and then I take the tree sheet, which has the trees with no shadow, and I put them in the overlay using the same selected tree number. And so when you see the zombies walk over this, I got there a little too late, but you would see the zombie being on top of the shadow but underneath the tree, which gives it a much nicer feel, because otherwise you'd see shadows on top of the zombies. So we could do that, and then we could shake the local shadow/tree, and so you'd get a real nice effect for when the zombie is nearby.
Yeah, that would actually simplify what I was thinking because you wouldn't have to try to merge the two.
Yeah, I didn't want to deal with the, there is an issue here with any kind of isometric relationship or whatever is like, when do you put the zombie in front of the tree or not in front of the tree? And I completely did not deal with that. So if you look at it enough, you'll see that the zombies are just coming right out of trees sometimes. But you know what? The point of this game is that you're going to be so busy trying not to get killed that you're not going to be noticing little details like that.
That's totally unrealistic. Zombies don't act that way.
Yeah, zombies don't come out of trees; they come out of the ground. I know. Okay, so what's the next deal here? I'm gonna ramp up the difficulty a little bit here so we can get some more zombies on the screen. And if people will want to remember this, is look for start level in common. I'm gonna put this up to 10. I don't want any archers, but I do want to get a few zombies on the screen. Actually, let's make this 14. Level 15 is when you first start to see archers, and I don't want any of those guys because they make my life difficult. Okay, so let me get some guys on the screen here, and I'll shoot them, and hopefully we'll get some chests out of this deal. There we go. We got a chest. Okay, so what happened there? We've already got all the code. We talked about this before for generating the enemies. Last week or the week before, I talked about how I elaborated upon the original code for generating enemies. And now we generate 3 kinds of enemies with different characteristics: the seeking versus the walking versus the continuous seeking, etc. And then, and the archers, of course, who seek a little bit and then they fire an arrow and then they seek some more. But no archers right now. So, but on top of that, what I wanted was the ability to add a pickup system. So I added some code for creating chests, which I'm going to show you in a moment. And the way it works is if you shoot a zombie, the arrow code, which is created in the player code, will know that it has hit a zombie because it has some checks, and then it will randomly drop a chest 20% of the time using the chest code. And it's worth noting before I proceed that there are other ways to kill zombies. Another way to kill a zombie is to have an archer shoot an arrow, and that arrow will hit a zombie and also kill it. So archers can kill zombies and you kill zombies. But when archers kill zombies, their arrow code does not create chests. So you don't get chests for zombies killed by archers. You only get them when you kill them yourself. Additionally, each of these traps, when we introduce them, you'll see that they can kill zombies and archers. But they don't drop chests either. You only get chests for shooting enemies with your arrows. So it's a balancing thing that I did so that you didn't get reliant upon using your traps and then sort of like get more and more chests and never have to use your arrows. So you have to think all the time, don't run out of chests. The only way to not run out of chests and therefore pickups is to use my arrows, and so I have to use both my traps and my arrows depending on the situation to keep myself going.